Okay, welcome to fifth video of topic 2.2, bonding between atoms. And in this video, we'll continue on with ionic bonding. We'll be looking at the second box in this table. So ionic compounds are continuous and are represented by empirical formulae. Write formulae for ionic compounds given the charges of the ions. Now, it is better for you to memorize how to work the the charges out for each ions, and also it will save a lot of time if you memorized all the polyatomic ions this year. So that'll be the requirement. Okay, slide 32 is where I want you to look at, or I'll be looking at or using. Let's look at how to name ionic compounds to start with. Now, rules are fairly simple. You need to name the cations first and then anion. The name of the cations is the same as the element. So if it's metal, like sodium, they'll stay as sodium. Except for the time you'll be looking at polyatomic ion. Now, there's only really one positively charged polyatomic ion, which is NH4+. NH4+ would be ammonium ion, and it's always the same. So you're gonna be starting off with ammonium. If you're dealing with element, non-metal element, being an ion, you have to change the ending. So the suffix needs to be changed to IDE. So whatever IDE. And I suggest you to just look at the non-metal elements on the periodic table and just calling them and changing the name to IDE, like oxide, chloride, fluoride, and so on. Again, if you had a polyatomic ion such as SO4 2-, that is a group, and that group of ion needs to be always called sulfate ion. That never changes. So if you had ammonium and sulfate, you just call it as ammonium sulfate. Exception would be H+. You can change the ending to be whatever ic acid, because often if H+ is present in a compound, ionic compound, it would be called as acid. So HCl would be, well, systematically you can still call it as hydrogen chloride, but it's commonly known as hydrochloric acid. All right, let's go through this together. NaCl, that will be sodium chloride. Na2O, sodium oxide. Hope you're keeping up with me. MgS, that would be magnesium sulfide, IDE ending. Mg3N2, Mg would be magnesium, N being ion would be magnesium nitride. AlF3 would be aluminium and fluoride. FLUO is the only spelling that you should be using. You can use, because that's on the periodic table. You will always have the periodic table with you. So if you make spelling mistake in fluoride, you will lose mark. Please also notice that the number of ions involved don't make any change in the name. All right, now let's look at the polyatomic ions. This year, it's better for you to memorize all of them. So OH-, hydroxide ion, NO3 is nitrate, NO2- is nitrite, ITE that is, and SO4 2- is sulfate ion. SO3 2- would be sulfite, ITE ending, ion. CO3 2- is carbonate, PO4 3- is phosphate, and PO3 3- is phosphite, ITE ending. Finally, CH3COO-. It's called acetate ion or ethanoate. Ethanoate is another name. It's actually the systematic name, but it's commonly known as acetate ion. If you put H+ on it, you call it as acetic acid, which is the acid that's in vinegar. Now, you can also find a link to Quizlet. Quizlet flashcard set for polyatomic ion on Canvas, or you can just look up my name, Kikuchi, on Quizlet to get to that flashcard. So I suggest you do that as soon as you can. And finally, the last one there, NH4 plus. Already mentioned that that's the only polyatomic, positively charged polyatomic ion you should really memorize. So yeah, that's what it is. NH4 plus is ammonium ion. NH3 with no charge is ammonia. Please remember that as well. Okay, so naming compounds that has polyatomic ion in it. What do you think? K or H would be potassium hydroxide, and Mg3 PO42. Numbers don't really matter. Mg is magnesium, PO4 is phosphate. Na2CO3 would be sodium and carbonate. HNO3 would be, there can be two names. Hydrogen nitrate is one way. If not, this is an acid. You call it as nitric acid. There, the last one, H2SO4. It's commonly known as sulfuric acid. Systematically, I guess you can name it as hydrogen sulfate, sulfuric acid. Right. Let's look at the chemical shorthand or writing the formula of it. Ionic compounds, they have overall neutral charge. So when you're writing formula, you need to make sure that overall positive charge and overall negative charge are balanced and cancelling out each other. Need to be 0 in total. For example, well, we can do the example later. The charge of each ion is called the valency. If it's an atom's becoming an ion, the valencies are used to write an ionic formulae. Use the periodic table to determine its valency. If you have forgotten, go back to the last video, please. Step 2, follow. I should have hidden that notes, but oh well. When you're writing ionic formula, you firstly write down the symbols that's involved, of ions involved, and write the valency below of each symbol, and cross over the numbers, and rewrite the formula, getting rid of all the numbers or putting brackets around. That's a bit small note. Make sure that the ones are not shown. Just like algebra, you will never write 1x or 1y. Equal numbers need to be simplified to 1 to 1. If there was 2 to 2 ratio, you need to simplify to 1 to 1. Brackets go around for more than 2 polyatomic ions. If you're only using 1, you don't have to use brackets at all. Alright, working out that you can show. Now, in this example, I'm using copper 2 ion, and also a chloride ion. Now, normally chloride ion is written as Cl minus, not Cl1 minus. But for this case, I'm just showing the valency of the ion. Cu2 plus is there and Cl minus is there. So writing the element and the charge is also written. You could cross over the numbers. So crisscrossing need to be done. So Cl1 minus 1 is written down below for Cu, and Cu2 plus 2 will be carried down to, it's a bit hard to see there, but the bottom of Cl. You need to make sure that that 1 is not shown in CuCl2. Sorry, the final formula should be written as CuCl2, not Cu1Cl2. Right, now this is where you can do exercise from Essentials workbook. Do question 1 and 2 in class. All right, see you in the next video.